Okay, I was asked to do a couple of these, just a couple of things on the circle. I don't really want to just put up the answers and stuff for people, but we'll just see how it goes. I'm just curious. I don't know where I'm putting this yet, but basically, whenever you get a circle question in the leave insert, it's going to be different. It's kind of always different depending on what year it is. But basically, as long as you see an equation of a circle, you want to find its center and its radius, and you can do that by using the log tables, which I've taken the circle part here. All I'll say is you don't need this at all. Well, I need to be more specific there. You don't need this at all, so you can get rid of that. And you don't need this at all. They're not on the leave insert anymore, so do away with them. You'll notice that we're given the equation of a circle. There's two ways that the equation can be written. It can be written like this, or it can be written like this. We have the second version, so we're going to use that. And you notice that we would see that the second version, you need to find G, F, and C. I haven't even read the question, but it's just always like you're going to need the center and the radius at some point. And the majority of the time you do, I think, get marks for it. So you'll notice that the thing in front of the G is 2x, the thing in front of the x is 2G. The thing in front of Rx is -2, so we would just say that, and then you divide both sides by 2, and you find out G is -1. You do it the exact same fashion for 2F. That's in front of the Y, so it should be equal to the 8, because that's also in front of the Y. You divide both sides by 4, you find out that by 2, you find out that F is 4. And then the center of the circle. The center of the circle is just going to be, it says that the center is just minus G and minus F. So it'd be minus 1 is 1, minus 4 is just -4. That's the center. And for the radius, what we would do is we'd fill in this part here. And you notice you get 1 squared plus -4 squared. And then you have minus C, C being the number at the very end, which for us is K. So that's problematic, but either way, we put in minus K. Now, we can't go any further. Well, we could, I suppose, go one step further and just change that to 17 minus K, just simply because that's what those two things turn into, 1 and 16. Then what you would do is, you can't do anything else, right? We found the center, we found our best attempt at the radius. So the question says that the circle has its equation, and it tells us the radius is 5√3. What is the value of K? So what we know is we can go to our radius and know that the answer should have been 5√K, or 5√3, sorry, instead of 17 minus K. And you'll notice now we just have an algebraic question to do. So what we would do is we would square both sides, because that's how you get rid of the square root symbols. Now if you square this, you guys will use your calculator. I suppose it'll be fine. You just get 75. Then you'd have minus K is equal to 58. But then you just have K is equal to minus 58. I think that's chill. I think that's right. Again, here's an equation of a circle. It's more like the first one this time, so I'm going to use that to reverse engineer it. I'm going to say, oh, if they have x minus 5 squared here, they must have put a 5 in place of the h. So I can say h would be 5. Instead of the k, they must have put a -2, so that it would have made the -2 in here, in the bracket, would have made, like in this guy, I don't know if you can see that, if you put the -2 in place of the k there, you would get y minus -2, which is y plus 2, which is what they did. And then they must have squared something to get 20, so it must have been they squared the square root of 20, which isn't really doable, but your calculator will tell you is 2√5, which is fine. You can use either of those. Then, so we know the center is 5 minus 2, and we know the radius is √20 or √2√5, up to you. Again, I haven't read the question yet. It says the circle this has a tangent at this point. Tangent, of course, being a straight line that hits it at one point. Just kind of glances off it, we'll say there. And tells us that's 9 minus 4. Find the slope of that tangent. What's key is the tangent is always perpendicular to the line, the radius that comes out to meet it from the center. But that's the radius. And we know what the center is, so we actually know that the radius is 2√5, and we know that the center is, I know it's getting a bit clustered the way I have it, the center is 5 minus 2. So we can't find the slope of this black line because we only have 1 point on it, and the formula y2 minus y1 over x2 minus x1 needs 2 points. So what we're actually going to do is we're going to take advantage of the fact that the tangent is perpendicular, and know that if we find one slope, the perpendicular slope will be upside down with its sign changed around. So what we're going to do is we're going to do the y2 minus y1 over x2 minus x1. That's what your slope formula is in your log tables, because it's a straight line. We're finding the slope of this red line, which we can do. You notice here we didn't actually need the radius, but that's okay. That's okay. If you do this in a certain way, you'd get minus 4 minus 2 over 9 minus 5, which works out to be minus 2 over 4, which is minus a half, I think. So that's the slope of the red line, but they asked for the slope of the tangent, which means the slope of the blue or black line. So what it would be if two lines are perpendicular, you have to be able to multiply their slopes together and get minus 1 as an answer. But basically the way that works out is that you always take the slope that you know about, flip it upside down and change its sign. If you flip that up and change its sign, you would get this, which is just 2. So the slope of the tangent is 2. Now, these didn't come through properly. I don't know if they came out through in order. I think this is the next one. Two circles, each have both the x-axis and the y-axis as tangents, and each contain the point 1 minus 8 as shown in the diagram. Find the equation of these circles. So what's important here is if it touches the x-axis, the y component is the same as the radius. So x-axis means y. Yeah, y is equal to the radius, right? And then if it touches the y-axis, it means that the x component is equal to the radius. Now, the way your teachers will probably tell you, the way they do it in maths is, instead of saying the x component, you can use or for it, they will say that the radius is equal to the modulus of f, but they won't even do that. They'll use the modulus of minus f, which I don't even really see the point of if you're going to do the modulus of it anyway. Or they'll use or is equal to the modulus of g, depending on the context. I just prefer using the ors. In my mind, it's just clearer. But if you do use my way and use the ors, what you have to do is take into account that depending on which of the 4 quadrants you're in, like if you're in this quadrant, both numbers are positive. If you're in the green one, the x number is going to be positive, but the y would be negative because it's under the y-axis. If you're in this black part here, they'd both be negative. And then if you're in the second green part up here, the y would be positive, but the x would be negative. So you have to kind of take that into account. And as we'll see here, like for example, we know that the centers of these two circles, because they're in these quadrants, will be, the first number will be a positive because the x value is a positive, and the second value will be a negative because it's underneath the x-axis. So it's underneath the x-axis, that means the y is negative, and it's to the right of the y-axis, which means the x value is going to be positive. So that's what that means, and that's what I'm going to run with for the time being. So we can kind of say the x-axis means the y is or, the y-axis means the x is or, and because of the quadrant we're in, we can say that the first one is going to be or, and the second number would be minus whatever or is. Because the radius can never be negative, the radius is always going to be positive. And just because it's underneath the x-axis, it would be a minus. So that would be the potential center for both of these. We know that that's a point that's on it. So there's a couple of ways of doing it. The one I'm just thinking of straight away is that basically the reason why that's super handy for us to do now is because if we can make an equation where there's only numbers and ors in it, we can solve for or. And you notice the red line here, or the red line here, alternatively, they would both be the radius of one of the circles in question. So if we found the distance from the center of the circle, which is or minus or, to 1 minus 8, the answer should also be or. So, and the maths will account for both of them, so we don't need to worry about which one it's doing. But if you use the distance formula, which is this guy, and that's going to be plus y2 minus y1 squared. If you do it in between this point here and this point here, so I'm going to call one of them x1, y1, and the other one x2, y2. I don't know if this is the easiest way to do it, but we'll see. the whole point being is we know that the distance formula should give us the radius as the answer, because the distance from this point to this point is the radius, or from this point to this point is the radius. So the distance formula between them should give us the radius. So when we sub it all in, what we will get is the square root of 1 minus or squared plus minus 8, and it's going to be minus minus or squared. Get rid of the square root, we square both sides. So we're going to get this, whoops. Here I'm just going to tidy it up ever so slightly by putting the two minuses together to make a plus. We get this. If you square this out, I'm going to skip a step or two, you'd end up with like this. Same over here, I'm going to skip a step and you'd end up with this. Then if you bring this or squared across, add all the like terms, I think you end up with or squared minus 18 or plus 65 equals 0. And then you can either use the minus b or you can use the brackets, and the brackets would be 5 and 13. This would be or and this would be or. And then we'd want them both to be minus, and you do equal 0. Again, the minus b will just get you to the very end here, which is or is equal to 13 and or is equal to 5. So those are the two contenders for what or is. So one of the centers would be, instead of or and minus or now, we know one of the centers would be 13 and minus 13, because the whole point was we found out what the center looked like, and if we knew what the radius was. And we did find out what the radius was, so we know for one of them the center is that and the radius is 13. I suppose I don't need to write that out, so it's already in the green. But the center for this one would be 5 comma minus 5, because the center is always going to be the radius and then minus the radius in that quadrant if they're touching both of the axes. Then to finish it does ask for the equation, so I'm just going to use the first one because it's easier to do and just fill in. They're just from the log tables. You can have a look and just see what I'm doing. I'm using the x minus h squared, y minus k squared, but I'm subbing in these numbers for h and k, and then this number for the or, but or squared would be 13 squared, which is 169. And then for the second guy, it would be x minus 5 squared plus y plus 5 squared equals 25. It is kind of late and I'm tired, and I'm afraid I might have made a mistake there looking at it. I can't tell why. I'm just having doubts. So if there's a mistake, by all means let me know so I can fix it, but that is a way of doing it. That is a suitable way of doing it, because we made an equation here in the second line, the first green line, and it only had numbers and the letter or, and that's kind of like the goal. If you can get an equation with just the one letter and a load of numbers that you're looking for, stellar. The reason we were able to do that is because the distance between the points is the radius, and one of the points was just numbers, and one of the points, as we kind of already figured out, was just ors. So that's pretty cool. This guy, don't mind any of this stuff, this is for one of the other videos. The circle is this equation. Again, I'm not going to even read the rest of it just yet. I'm going to say, well, that means that the 2g has to equal minus 4. Divide both sides by 2, g is equal to minus 2. 2f is equal to plus 2. Divide both sides by 2, f is equal to 1. The center, if you recall, though, is going to be minus g and minus f if you look in the log tables. So that means that the center is going to be plus 2 and minus 1, because you just take the wrong signs if you get me of g and f. Then the radius, if we follow the formula also, would be 2 squared plus 1 squared. Now it should be technically minus 2, but because you're squaring it anyway, it doesn't really matter. You can put it in if you want. Just be careful of how you type it in the calculator. If you put this in, it's a minus. In the formula, it's a minus c here, but the c is already a minus, so it would be minus minus 4. So I put it in as a plus 4. And then when you put that in your calculator, the answer is 3. So we know that the radius of this circle from here to anywhere on the edge of the circle is 3, and we know that the center at A is 2 comma minus 1. Now what's the question actually asking? So we can kind of almost ignore that. The point A is at the center of the circle, chill. The line L is a tangent to C at the point T, so we can kind of see that it's a straight line at T. Not exactly, that's more so where it is, but that's okay. So we don't need that as shown in the diagram. Yep. The point B is on the line, we know that. Now, all that's asking is then, what is find BT, and those two lines either side are the modulus bar, so they just mean find the distance from B to T. They're literally asking us for the length of this line here. The exact red line there from B until T. Now, impossible to do because we don't have T, so we can't just use the distance formula. I said impossible, but I just meant impossible to actually use the distance formula. Instead, again, remember, tangent is perpendicular to the radius that comes out to meet it always. And in the previous one we did what we, oh my god. Ooh, in the previous one what we did was we kind of said, oh well then we can invert the slopes to get the perpendicular one. But instead what we're going to do here is, and it's another common enough thing they ask you to do, is we're going to do this. Now the lines are slightly off after I criticized theirs, mine are off slightly too. But we've made a right angle triangle. Roughly like so. That's that. We know the bottom here is 3 because you notice this line here is actually the radius of the circle, and we found the radius to be 3 before, so that's, again, finding it is always kind of handy. We're looking for this guy, so we won't know him straight away. They said find the length of B to T, and that's what we're doing. So we need to, if we got this guy, we'd be able to do Pythagoras' theorem, and we can do that because you'll notice that that's the distance from this point to this point, and we can just use the distance formula there. So what we would do is we'd use the distance formula again. I'm not going to write it out in its entirety. I'm just going to do it out if that's okay, because it's over here in the red. So we'd have 8 minus 1 squared plus 5 minus 2 squared. And then when you do that, you will get 9 squared plus 3 squared, which is the square root of 81, or no, yeah, square root of 81 plus 9, so 90. And that is 3 square root of 90, or 3 root 10, I think. So that is the length of this guy. So to find the last remaining length, what we would do is we'd use Pythagoras' theorem, and I'll do it the way most of you guys know rather than the way I would do it. And you would do this, and the side that's always on its own is the hypotenuse, which is the side across from the 90 degrees. So the 3 root 10 is the one that has to go on its own. So we'd say 3 root 10 squared is equal to, I'll say 3 squared plus b squared, and we'll act like this was b and we were looking for b. As long as the hypotenuse is the one on its own, that's okay. That is going to be 90, that is going to be 9, that is going to be b squared. That means if you bring the 9 over, make it a minus. It would be like so, and then we'd have this. And then you square root on both sides and you get this, and that is the length of b to t. Problem solved. Pretty cool. I don't know if this is the next one, I'll be honest with you, but I'll probably just do it anyway. I don't know, they're all in a weird order, but like once the stuff is done, I don't think they're connected at all ever, so it's fine. It's not like we're gonna need that answer for somewhere else, if you get me. So here, show that these two circles touch externally. You'll notice on a diagram the way that would look is that we have a circle that's chilling like so, and then we have another circle like so. And they're just bouncing off each other like that. And what that is, you'll notice that the radius from here to the point of contact, this guy, plus this guy, together must make the distance between the centers. So the two radii added together should be equal to this full length here. So again, maybe I should have done this before we actually dove into it, but equations of circles, find the center and radius. Now here they're actually going to be like hugely important. We do need them, but even if I hadn't seen it, I would have just done it anyway. So this one we would have said 2g is equal to 4, 2f is equal to minus 2, g is equal to 2, f is equal to minus 1. So therefore the center would be minus 2 and 1. The radius we would do by doing 2 squared. Now I'm going to put in the minus this time just because I should have done it the last time, I was just lazy. Minus 95 is plus 95. And when you do that, it would be 10. So the center of the first guy, that's that guy. It's a shit arrow, but like live with it. Then this guy we know they must have subbed in for h and k, because it was x minus h, then h must be 7. This was y minus k, so that means k must be 13. And this was r squared, so that must mean r is 5, because they must have squared 5. So that means we know the center is 7 and 13, and the radius is 5. Now, the distance between the two centers would be just doing the distance formula between the two centers that we found. And I'm going to just kind of again fly through this, if that's all right, because I think you guys should be able to just figure out the distance formula, hopefully. If I'm wrong, I'm wrong. But again, you could just throw that all in your calculator in one go, and you will get 116. No, that's 144. That's 25. 144. Oh no, it's not 25. It's 81. See, there you go. 144 and 81 is 225. So you'd have to square the 225. And yeah, that's 15. And you'll notice that what happens if you add the two radii together, you get 15. So yeah, that's how you show they touch externally. You've shown that the two radiuses put together, the two red lines put together, is the same length as the green line. And the green line, you'll notice I found by doing the distance formula between the two centers, and the two red lines you can put together by adding the two radii together. And that's it. Yeah, they do touch externally. Internally would be, you have to prove that instead, here we did r plus r is equal to the distance. If they were touching internally, it would be d is equal to r1 minus r2. That wasn't the case here. I'm just giving you a heads up. Now, this question, I'm not really too pushed with people being able to do this. Like, you know, one of the people who got 65, she couldn't do it, so I honestly couldn't give less of a shit. There's an infinite number of circles which touch circle C externally at the same point that S touches C. Find the coordinates of the centers of one of these circles apart from circle S. So basically what they're saying is, imagine this was the small circle S. They're saying you could have like an infinite number of circles that also touch. Now, none of those really are touching, but they all touch the first circle, this guy here. They all touch it at the same point that the original one touched it, which is true. It's just that basically the center would just be further away, but it'd be in the same kind of pattern. So so if the center of, now do I need to, which way around did they ask it? There's which touch circle C. Circle C was the first one. So yeah, okay, the first one is actually C. I did the diagram slightly wrong, but basically they're saying there's a center for C, which was minus 2 and 1. And there was a center for S, which was 7 and 13. So that would be here. Basically, it's as long as you find another center along this kind of red line here. Now we kind of want to make sure it's further out than the actual, so the actual circle will be like here and here. We want to make sure you don't get in this section, because if you do, then it wouldn't be touching externally. Because you can't have the center of the circle inside of the circle that you want to touch externally. It just doesn't make sense. So it's kind of safer just to make sure you go further than the first circle. So you want to go somewhere along this part of the line after the 713. So basically what you could do is you could say, well, to get from minus 2 to 17, or to get from minus 2 to 7, they must have added on 9. And to get from 1 to 13, you could have added on 12. So just add on, instead of adding on plus 9 and 12, you could add on double that. You could just add on 18 and 24, because then it's in the same kind of ratio. It's still 3 to 4 is the every time you go across 3, you go up 4 is basically the ratio. And as long as you do that, you stay on the dotted line. Again, it's easier to pick bigger ones, so you're definitely past it. You're not inside of the original circle, so that the new center you could potentially pick would be 16 and 25 maybe. I think that's right. It's one of the answers. There's obviously an infinite number, so there's a shit ton of answers you can get there. You could also have done plus, it's going to be a weird one. Yeah, I won't do that. I'll do plus 12 and plus 16 then. That would also work, because again, I added 3 on here from here to here, and I added 4 from here to here, so it's still in the ratio of 3 to 4, so that's okay. You could have done 15 to 20. As long as you're adding on like a consistent ratio like that, where it's still going up by 3s in the first one, going up by 4s in the second one, you would stay on the red line. You want to make sure it's bigger than the +9, +12, just to be sure that you're definitely outside of the original circle. But yeah, that's one of the answers, I think. Again, it is late. That question was, in my mind, a bit stupid. People just couldn't do it. I go for this one next, just because it's the... Is it too late? Basically, if a point is on a circle, we should be able to sub it in for its equation. So we should be able to call that x. We should be able to call that y. Just sub in the equation should work. If the point is on a circle, that's what should happen. If the point was inside of the circle, like here it was here, we should be able to sub it in, and all of this would compute to a number that's smaller than the 65. If it was outside, we'd get all of this computing to a number bigger than 65. But I'm just going to do it, it's on it, so we should be able to sub in and it should work. So everywhere we see an x, I'm going to put a -2. Everywhere we see a y, I'm going to put a k. 65. If you put that in the calculator, you get 16. This one, because it has the k, you can't put it in the calculator. You actually have to just multiply it out like that. And you'd get this. You bring the 65 over, because you notice you have a k squared, a k in a number, so it looks like it's going to be minus b. That's going to be 25. You bring the 60 over, so it should be minus 40, I think. Yup. And then you can do the minus b again, or you can do the brackets. The brackets are just quicker for people who do maths all day, every day. You don't need to worry about it. The minus b will generally give you what you're looking for, like 90-something% of the time nowadays. And then k is equal to -4, k is equal to 10. You should technically know how to do it the other way, but just the numbers can be a bit much for people who aren't doing this all day, every day. Those are your two possible values for k. That's all it is. So it just means that on the graph, if you were to graph it, the circle would be like this. Because they both have the same x value, it means that on the x-axis, if you go to -2, then it means that both of them are going to be on this kind of vertical line here and here. And then this one looks like it would be the point -2 in the x and then -4 in the y, which would fit this because it's -2 first, and then the k would be -4. Or it could be this point here, which looks like it would be -2 and then 10, because then again it starts with -2, but instead of k we put 10 this time. That's all. You don't need to do the diagram, obviously. You just need to find k and you're done. 2 circles. What's this? 2 circles. 2 circles have the center on the x-axis. Each circle has a radius of 5. The point lies on each circle. Again, the point line on the circle means we should be able to sub it in. I don't know. I can't. That's not relevant from the way I do this. Actually, I remember. Find the equation of both. For this one, I like to do a little diagram just to kind of highlight what's going on. So there's the x-axis hypothetically. Okay, so there was a little interruption there, but I think I've been able to pause it okay. You wouldn't hear anything, and I haven't disrupted my maths knowledge at all. But basically, it says that both of these circles, so the 0.14, if this is the x-axis, the 0.14 would be like up here somewhere, right? Because it has to be at a height of 4. So it has to be 4 above the x-axis. So if the 2 circles have their centers on the x-axis and go through that, one of them might look something like this. Now obviously that's not on thing. Be more so. Yeah, I just don't like that. I'm just going to try to move the circle instead. I know that's just me being a bit finicky about it, but sure, look. So we'd have that. And then we could also have another one like that. Yeah, look, it's only supposed to be a rough thing. I'm just getting myself worked up over nonsense. But basically, let's pretend that those 2 circles, I can just raise the green one. I was being, just the maths didn't look right in my head, but I just need to get over it. So, imagine the 2 circles have centers on the x-axis. Now, they might overlap through the centers, they might not. It's just the way I've done my diagram. It's probably not the case. Don't think that, like, the center of this circle should really be here. I was afraid that if I did that, though, people would be like, oh, that circle must go through the center as well. Not necessarily true. I'm just kind of ballparking it here. Now the way I do that, so two circles with centers on the x-axis go through that point that's above the x-axis. So these circles must collide like this. There's no way the circles only touch externally like that, because then you can't have the point. You can't, like, they can't have the x-axis there and the point there. You know, the only way they'd be able to intersect if the point was there, but the point can't be there because it has a y value of 4. So it has to be up above the x-axis. It can't be on the x-axis itself. So I know that's difficult to come up with that concept yourself. I get that. I don't really know what to do. I'd say just mess around with it. But as a result, we know both of the centers are something and 0, because their y values has to be 0. We just don't know what their x values are. However, there's kind of a hint that if you were to draw a line straight down here, that x value would be 1, because that is the x value of the point here. This is, I know this is finicky, people aren't going to like this, but the x value is 1 directly under that point, because the x value of that point is 1. So what we would need to do is find out the length of this green part and find out the length of this green part, and then add and subtract it onto 1 to find out where the centers, like how far to the right this center is and how far to the left this center is. So what we would do is, do I need another color just because it's going to just look messy? Basically what you're going to do is, you notice this blue line here is the radius of the circle, which we know is 5. So basically what we've done is we made, I don't know if you guys are going to be able to see it. I know I can see it in my own head because I've done it. We've made this triangle. Coloring it in was a good idea. We made this triangle. We know this is 5 because it is the radius of the circle. And we know this line is blue. I could also have picked this triangle instead and done it on the left instead. I just happened to pick the right one. Doesn't matter. So we know that the radius is 5, so we know that the hypotenuse of this triangle would be 5. We know that the point was at a height of 4. It was 4 up. So that means we know the height of the triangle must be 4. And if you do Pythagoras again, here's a right angle. This is the hypotenuse. You do Pythagoras where this is the c squared, because the hypotenuse always has to be on its own. I've given the answer away, sorry. You do this. You get 25 is equal to 16. I'm trying to give the answer away again. Plus b squared, you bring the 16 over, it goes a minus, you end up with 25 minus 16 is equal to b squared, you end up with 9 is equal to b squared, you end up with 3 is equal to b when you square root both sides. So that means the length of this line is 3, so that means if we start at 1 here and bounce 3 spaces to the right, we'd end up with this, which is 4, and if we bounce 3, it works out the exact same in reverse this way, but instead of going from 1 up to 4, we'd go 1 down to minus 2, because it's still 3 bounces away from 1. This is a very finicky one. I wouldn't be too upset if you don't fully understand this. You can give it a shot. You can ask me about it. But the two centers are minus 2 and 0 and 4 and 0. Both of them have a radius of 5. Now it does actually ask for the equation of both of them. So the equation of this guy, again, just subbing in for h and k, would be this. Now weirdly, because that's a 0, you'd have y minus 0, but I'm just going to write y squared, because y minus 0 squared is just y squared, which is y squared, because anything take away 0, it's just itself. 7 minus 0, oh Jesus, 7 minus 0 is 7, 18 minus 0 is 18, so that must mean y minus 0 is y. That's the logic I was using there. You don't need to worry all about that. You could just sub in the 0 yourself and see for yourself, or just leave it as y minus 0. I think they would have accepted if I had just done that. I just wanted you guys to kind of see that as well. And then it must be equal to r squared, which is 25, because the radius for both was 5, as we said. If you do the same here, you'd get x minus 4. Here it was a plus 2, because I subbed in a minus 2. Here again, it would be a y squared, because the 0. And then it would be equal to 25. And those are the two equations of the two circles that fit this information. That one I can't, with a lot of them, I can kind of say to you, oh, this is the line of thinking you should go with. I remember seeing this one. This took me a while to think of when I saw it. I just didn't really think of using the triangle here. I'm sure there's other ways of doing it. Because the fact they tell you that point lies on the circle, you could probably sub it into an equation of a circle. And then sub in the 5. And sub in, yeah, you could probably do that actually. Yeah, what you could do to solve it is, okay, I'll just show you real quick. If the point 1, 4 is on the edge of the circle, we should be able to sub it in for x and y, like I did over here on this one. I don't know if you can see the cursor too well. So we should be able to sub your boy in here. So we'd say that's an x, that's the y. If we were to sub it into the equation of the circle formula, we would say instead of x minus h, we'd say 1 minus h, because we don't know what h is yet. And then we'd say instead of the y, we'd say 4. Instead of the k, we would say 0, because we knew when it's touching when the two centers are on the x-axis, the y value has to be 0. And they told us both the centers are 5, so the radius would be the radius squared would be 25. And then if you do actually, I never would have thought to do it this way before, just looking at it now. So I might be making a mistake. I don't think so. And then you could say, oh, well then it's just a quadratic in terms of h. And then that would be minus 8, I think. You do the two things, you get h. Oh yeah, this is nice. That's a nicer way of doing it, probably. That should be a plus 2 there, though, sorry. And then you get h is equal to 4 and h is equal to 2. Okay, I like that. Well, minus 2. I like that way. You don't need to use the diagram and shit. Maybe go with the red way. So all I did was I said if a point is on the circle, like here, we should be able to sub in for the x and the y. The center, because it's on the x-axis, we knew the y value had to be 0. We just didn't know what the x value was. And when you're subbing it in, because you knew 5 squared, everything you sub in is either a number or the single letter h. That's much better. I much prefer that way. You still have to do these two bits in the end here, but it's effectively you're just kind of subbing it back into here with, well, okay, without the 1 and the 4. Okay, I much prefer the red way. That's probably how I'll do it from now on. Sorry to anyone I've taught the other way. My bad. Now, this one is a very rare one because it has a chord. I did try to cut out a lot of the stuff the other person did. The person who sent these to me, because I don't know, it just feels weird putting their stuff in it. Yeah, sorry. Handwriting's pretty good though. You're fine. So the circle K and the highlighting. Wow. Circle K has this center and a chord AB. A chord is a line that touches a circle twice. So this line is a chord. This line is barely a chord. I fucked that up almost. This is a chord. This is a chord. This is a chord. This is not a chord. And this is not a chord. It is a tangent. All the others technically hit it twice. So they would all be chords, like a chord on a guitar string, because you know the way the chords on a guitar string go over the hole in the middle. They're all hitting the circle twice in the middle of the guitar. That's how I think of it. So A to B is definitely a chord. Now, the thing about chords, they're very rare when they come up in the Leaving Cert, so I don't always talk about them. But the thing about a chord is the perpendicular bisector of it always goes through the center of the circle. Now the perpendicular means it's 90 degrees. Bisector means it splits it in half. So this part and this part should be equal, because it should be that the whole thing was split into 2 equal parts, and those 2 red parts represent the 2 equal parts. So the perpendicular bisector should always go to the center. So this line, because now how do we know actually it's a perpendicular? It says the circle is a chord. The chord is, now very rarely they'll do this, but there's something in the words that is not in the question. So you want to always read the question, even though people don't like the words, and I say very often it's a lot you can skip. Sometimes you just want to read through it first and make sure there's nothing that's missing. The point 3,2 is the midpoint of AB. So it is the bisector. Those two are definitely split in half. And then this goes through the center. So instead of beforehand I said that the perpendicular bisector, if we drew the perpendicular bisector of a chord, for example, let's say we have that, then midway between like here and here would be like here. And if we did a line from that point that is perpendicular to the red line, it should go through the center. Mine is slightly scuffed, but don't worry about it. It should go through the center. No, well, maybe, I don't know. Their center looks slightly off as well, but that could just be me being stubborn. But that's the idea of a chord. The perpendicular bisector, as long as you draw a line that's perpendicular and goes through the middle of the chord. When I say the middle, obviously when you saw my tangent or my chord like that, it's not in the middle of the blue line. Like here, it's the middle of where it touches the circles, like here and here, the middle of that part. So here, when that's perpendicular, it will go through the center. But instead of drawing a perpendicular bisector and knowing it goes through the center, we know we have a bisector that goes through the center, so therefore it must in reverse be perpendicular. All three things, if two of the three things are true, then the third one has to be true. It has to just follow through. There's no way you could have a perpendicular line that goes through the center. Well, okay, that's a bad example. Hopefully you know what I'm trying to say. I'm just fucking up the words. But yeah, we know it must be perpendicular. Find the radius of K. It is, first off, circle K. Yeah, I know, gas. But basically they're saying to find the radius of the circle K, so that could be this line, it could be this line, it could be this line, it could be this line. Makes more sense though, if you think about it, to find the length of, this line, because not only is that the radius of the circle, it finishes off this triangle. And because we know this is a bisector that goes through the center of the circle, it must be a perpendicular bisector, so we knew this was 90. Then we have a right angle triangle again, like so. Right angled, this is the hypotenuse, this is from C to D. Yeah, I'll do the D, the C, and the B. We know that the full A to B, as they told us, is 4 root 3, and they also told us it was split in half, so this must be half of what 4 root 3 is. So what you would do is you do 4 root 3 divided by 2 on your calculator, and it is 2 root 3. This guy we would get by doing the distance formula again from C to D, which I think you'll be okay with because I've done it a couple of times already. Hopefully you'll be okay with that. So you'd have 3 minus 1 squared plus 2 minus 2 squared, and you do that and you would get 4 and 4, so you get the square root of 32, and the square root of 32 is square root of 32 is 4 root 2. Yeah, I think that's right. Is that right? I think that's right. Oh, no, it's not right at all. Yep. So I shouldn't, I'll do it. But that's 3 minus 1. I assumed it was 3 plus 1 because I don't know. So that would be 2 squared, which is 4. That would be 4 squared, which is 16. And that would be the square root of 20 again, weirdly. That's convenient. The square root of 20, that would be 2 root 5. I think that one's right this time, right? Don't judge me. All right, I'm trying my best. That would be 2 root 5 over here because that is the length from C to D, and those are the 2 points I put into the distance formula. So again, we're going to use Pythagoras' theorem now to find out the third side, because you notice that would be the red line here, which you'll notice is the radius of the circle, which you'll notice is what they asked for. So, what would I do? I would say, so the C squared we don't know, but the other two lads we do know. You want to put brackets on it, because if you put the squared in without the brackets, it thinks I think the calculator, I don't know, I think it might think you're just squaring the root 5. And the same with this lad. 2 root 5 squared would be the 20 again, and 2 root 3 squared would be 12, so it'd be 32. And okay, so C's, I think, right, the logic is all there. I'm just kind of maybe fucking up the numbers. If you think, just do every bit of it on the calculator, I suppose, and just make sure the method is fine. Now this would be 4 root 2. Oh yeah, that's your answer in the form A root B. Sick. Whenever it says give your answer in the form, don't read that until you have an answer. People very often read that and they're like, oh, there has to be an A root B in it somewhere. But like, there's no point bogging yourself down trying to like figure that out if you can't do it. You know what I mean? Focus on the start, get an answer, and then only when you have an answer should you bother reading give your answer, because if you don't have an answer, then that's just going to confuse you. You notice my answer does fit it because it's 4 root 2, so instead of A there's 4, instead of B there's 2, and they are natural numbers, which is what that says. Now the last one, this is the most adventurous one. So it tells you that, so this is very similar to one we did earlier, and I'll kind of explain it afterwards. So this line here is the tangent, and they tell us that that's the equation of the tangent. They didn't give us the equation of a circle, so we don't need to find the center and radius just yet. They tell us it is in the first quadrant, which for those of you heathens that do not know, it works like this. We start on the top right and go counterclockwise. I know none of you know your left or right or what clockwise is, so that's, a blight on society. So if it's in the top right quadrant though, earlier what I was saying is, remember when I was colouring it in, I was saying that then it would be in this quadrant it would be plus and plus, because the x values are positive and the y values are positive. Here it would be minus and a plus, because the y values are positive but the x's aren't. Here would be minus and minus, because they're all minuses. That looks like a face, I know, I see his name. And then that would be a plus on the x with a minus on the y, because it's underneath the x value, or underneath the x-axis, but it's the x value is on the right of the y-axis, so that's how that would work. It's just because basically positive numbers, negative numbers, same shit this way, and you kind of just combine all them to get the 4 different scenarios. And that's going to be important if you are going to do it my way of using the OR. If you want to look into using the modulus of f and the modulus of g instead of OR, that's fine. I think it's something like that. I just don't really do it that way. I just never liked it. I don't know why. Even when I was in school, I never liked it. So I just never really picked up on it. I just kind of did it this way. People would argue this is not wrong, but it would lead to difficulties if it doesn't tell you what quadrant it's in. But yeah, I suppose that's right. If they don't tell you what quadrant it's in, that does lead to issues. And you might have to say that the radius is equal to the modulus of whatever is in the center. Because let's say it's the center works out to be here, and it is like 3 and minus 4. But it's touching, that's a bad circle, as we can all see. If it's touching the x-axis, that means the y value is the radius. So what we would do is we would say that the modulus of the y value is equal to the radius, which would mean 4 is equal to the radius, yeah. So it does work. I don't know. I have just always done it that way, and I've always managed to get it to work, but maybe I need to work on doing that, actually, because you guys... Maybe there's a question that'll come up that'll stump me doing it my way, and I'll have to figure it out. Maybe you guys just don't like my way. Maybe you guys don't want to delve too deep enough into the world of maths to figure out why one of the ways works better than the others. I don't know. It's up to you guys. But circle being in the first quadrant, I'm going to follow this logic. It's touching both axes again, like in the previous one. Axes being the plural of axis. So we know that the x value has to be the radius and the y value has to be the radius. So we know the center is going to be or, comma, or, because they're both the radius because of touching the x-axis, the y is or, and touching the y-axis, the x is or, and because it follows the plus plus, right? Hopefully I've summed up all that. I kind of got lost in the sauce myself there a bit. But, again, the tangent is always perpendicular to the line that comes out to the radius that comes out to meet it from the center. But it has to touch it at the point of contact where the circle and the tangent touch each other. Now, that's not making a straight line for some reason. It's making me look a fool. Yep. So this is perpendicular yet again. Any tangent is going to be perpendicular to the line that comes out to meet it at the point of contact. Obviously, this line wouldn't be perpendicular, right? So it's always the one that comes out to meet it at the point of contact. And then what we would do is we'd highlight the fact that the tangent is 3x minus 4y. So we've actually done all of the things I can think of that the tangent is important for. When we've done this, we'll have done all of them. There's 3 of them. There was the first one where we found out that the slopes can be inverted. So we found the slope of one of the previous questions, we found the slope of the radius was minus 1 over 2. And when we flipped it upside down and changed the sign, it became plus 2 over 1, which is just 2. So that's one of the things they can ask you to do with a tangent. Use one to find the slope of one to find the slope of the other. We also did it where we said, oh, we can turn this into a right angle triangle because we know it's perpendicular, so that means there's going to be a right angle and the side across from it. When we did it from, I think it was B down to the center, then we knew that that was going to be the hypotenuse because it was across from the right angle. The third thing that we can also do is using the perpendicular distance formula. And that formula is on page 19 of your log tables as well. And it's basically finding the distance between a point and a line, but it's always finding the distance perpendicularly between a point and a line. So imagine you have a point here and a line here. Technically, that's a line, or that's a length, and 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 that's a length. But we just decided that it will always be the length that joins the dot to the line in a perpendicular manner. So like this. It's always going to be that red one instead of any of the blue ones. That's just kind of what that formula, we decided that's what it's going to be for. We've made it perfect for that. So, Also, the thing about this red line is it's the radius of the circle, so it should also be or. And the key to that is, again, like with earlier, now it's slightly different. We know that the answer to this should be the radius because the line is a tangent. The perpendicular distance from this point here to this line here is going to give us this red line here. And we know that red line is the radius. So the answer to this formula, when we sub in this for x1, y1, and these for the ABC, the answer should be the radius, and that's what we're kind of doing here. Now I know it's hard for you, might be hard unless you have your log tables open on page 19. It tells you on the right where to get x1, y1 from. It tells you where to get A, B, and C from. I'll write them down here. I suppose x1 is equal to or, y1 is also equal to or. A is the thing in front of the x in the equation of the line, so therefore it would be 3. B is the thing in front of the y, so it would be minus 4. And then C is the thing on its own, so it would be the plus 6. In order for this to work, everything has to be on one side equals to 0. That's what the formula kind of requires. It tells you that in the log tables. And we know that when we sub it all in, we should be equal to or. Now, I remember this actually works out to be a horrible looking modulus, but we'll see. So it'll be 3 times or minus 4 times or plus 6 modulus over the square root of 3 squared plus minus 4 squared. Now you wouldn't need the bracket there, else the calculator does something wrong. And the answer should be the radius, because it should be the length of this red line, which I can't stress enough is the radius of the circle. The perpendicular distance formula between the center of a circle and any of its tangents should give you the radius as an answer. That's the important bit. Because that's what this whole thing is depending on, because basically when we sub it in, you'll notice everything in here now is numbers or the letter or something we can put in the calculator, and that's what's imperative. That's what makes it super handy for us. I'll just change it again because I know I'm going to get the blue kind of, well, no, I'll just kind of do this. I really didn't like that. Kind of like this maybe. I'm still not a fan, I'll be honest with you. But on top you end up with 3 or minus 4 or plus 6 over, when you do that, that's the square root of 25. It's still equal to or, I should have put that in. Yeah. Then on top you'd end up with minus or plus 6 over 5 equals or. Multiply both sides by 5 and you get the modulus of minus or plus 6 equals 5 or. Now, how do you get rid of modulus bars? Is this right? Have I messed this up? I think this is right. It's just the numbers I thought were much bigger. There's 2 ways of doing it. You can either square both sides and then get rid of the modulus. It's not that the squared goes. It's just the modulus bars are irrelevant. You still do have to square it out. And what you'd end up with is or squared minus 12 or plus 36 equals to, here you'd have to square everything. Let me just see. Oh yeah, okay. So you'd square everything and you get 5 squared is 25, or squared is or squared. Bring that over. Well, I'd bring everything over to the right because you realize we're going to get another quadratic. If you bring everything over to the right, you get 25 or squared minus or squared, so it'll be a positive here. It doesn't matter if you brought it to the left. That's still fine. But you get this. Now, oh god. What some people can do is, you can do the minus b straight away here. Some freaks can do the brackets. Either way, depending on what you're doing, you can recognize you can divide that whole line by 12. What you'd end up with is 0 is equal to 2 or squared plus or minus 3, which is a lot easier to do. It's just going to be like so. It's still equal to 0, so you put both. I've been skipping that step the whole time. I should probably do this, but I think you're all, again, you guys can just use the minus b at that point. And then or is equal to minus 3 over 2, and or is equal to 1. And then what you'd have to do is, now I've kind of run out of room, but what you have to do is go back and actually find the equation of that circle. Now here's the thing, there was 2 answers in the question though. It said equation singular. That is because you can't have a circle where the radius is minus 3 over 2. So you kind of go, ignore him, we're going to focus on your boy here. And we would finish it off by just filling in the center. In the center we initially decided was or. We found out that that would only exist if or is 1. So the center is actually 1 comma 1. And the radius is also 1, just because that's true here. And you fill all that in into x minus h, which is 1 squared, plus y minus k, which is 1 also squared, which is equal to r squared, which is 1 squared, which is 1. I think that's your answer. Happy days. Now, if you're an alt person, you're all weird about it. What you could also do is for the modulus bars is, instead of squaring both sides, so if we go back to imagine we're in a universe before we squared both sides, another thing you can do with modulus bars is split it up where you put the stuff inside the modulus bars equal to the positive thing, or, and you do have to do this, this is not me saying you can do one or the other, this is me saying you'd have to do both, put it equal to the negative version. And then you would bring the or across and it would become a plus or. And then you'd have 6 equal to 6 or, which then you divide both sides by 6 and you get 1 is equal to or. And then over here you'd get 6 is equal to minus 5 or plus or. 6 is equal to minus 4 or. My ors are getting a bit weird, but don't judge me. Divide both sides by minus 4, you'd get minus 3 over 2 is equal to or. You notice those are the same answers here, and then you can carry on again. You'd say, oh, well, we can't have or be negative. We're going to go with your boy. We fit in the equation of the circle. We get that. So green is alternative to kind of like the red ending, but you still have to have the last line. Okay, that's all that shit. Hopefully it's all correct. Again, if there's an issue, let me know.